All right, welcome, ladies and gentlemen, back to calculus. We are going to begin our unit 4. This is going to be a somewhat short unit, only I think 4 lessons in it. First lesson, though, we're going to start looking at the derivatives of the trigonometric functions. So we're going to start looking at sine and cosine, and then we're going to create the rules for the other 3 as we continue. All right, so let's go ahead and get into it. We're going to look first at the derivatives of sine and cosine, as I mentioned. And we're going to look at the graphs first. So, some of you guys' worst nightmares is the fact that we are beginning trigonometry again. But let's take a look at sine. Let's take a look at sine first. The function sine, let's go ahead and change my pen colors here. We got green for sine here. Okay, so sine is going to come up here like this. It's going to come down here like this. And it's going to come back up here like this. And it continues forever into eternity. And if you recall that this is 2 pi, 1 full period. This is at pi. This is at pi halves. And this is at negative pi, or sorry, at 3 pi halves. And the maximum is 1 and the minimum is negative 1. This is for the parent function sine of x. So what we want to look at now is the possibilities of a derivative. And the things we remember about derivatives is the fact that the derivative is the slope of the tangent line. So if we start looking at the in blue here, d dx of sine of x. If you look here at pi halves, you'll notice the slope of that tangent line is 0. So the derivative is 0 at pi halves. And the same thing goes for 3 pi halves. Well, that's pretty interesting. Then, if you look at the other 3 critical points, the zeros for sine of x, this, if we kind of just were to guess, the slope right here at 0 kind of looks like a 1. So let's say it's 1 for now. And the same thing goes at pi. It kind of looks like it might be a negative 1 slope. Now we're just kind of estimating here. And we look back here at 2 pi, and it looks like the positive slope of 1. So the slope there is 1, so the derivative is 1. Well, if you were to continue doing this, the slope looks like it's slowly getting smaller and smaller and smaller and smaller and smaller, getting to 0. Okay, so the slope's getting smaller and smaller and smaller and smaller and getting to 0. And then the slope is getting steeper and steeper and steeper, but more negative. Okay, so it's getting steeper and steeper and steeper. It's getting closer to negative 1. And then it goes the other direction. And then it kind of comes back up. And, well, that actually kind of looks like it's going to continue to go down like that. And this is going to go down like this. Well, we know what that function is. That function is cosine of x. So if we were just looking at the kind of the estimations of slopes of tangent lines, we would see that given sine of x, the derivative is actually going to be cosine. And that's actually what we're going to say here as our first definition. The derivative of sine is cosine. Well, let's go ahead and look the same thing as the cosine here. Let's go ahead and change back to red. Let's get our axes down here, and let's take a look at cosine itself. Oops. And dang it. Let's go to blue. Cosine looks like this, as we just mentioned. And out here is 2 pi. Here's 3 pi halves. Here's pi halves, and here's at 0. Maximum of 1, minimum is negative 1. If we were to think about this blue line being cosine of x, and we were to look at, okay, well, what's the derivative of this using just an estimation for slopes? So d dx of cosine of x is going to be this green line. Well, we know that the slope is 0 there, 0 here, and 0 here. So we're going to put in those zeros for the derivatives. And then we're going to look at, okay, well, the slope is going negative, 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 and it looks right about there to be -1. And then it's still negative, getting less negative, less negative, less negative, and then more negative, positive and more positive, and it comes up to 1. And we do the same thing before, and we kind of connect these like so. We get what looks like a sine function, only something's wrong. Sine usually goes up and back down, but in this case it goes down first, back up, which just means it's the opposite of sine of x, which tells us that the derivative of cosine is negative sine. This is extremely important for us because these two functions are what's going to help us determine these four functions' derivatives. And what we're going to do here is we're going to use our rules that we already know in order to find the derivatives of secant, cosecant, tangent, and cotangent. So let's start with secant. We know the secant of x is equal to 1 over cosine of x. So if we were to find the derivative of secant, it's like finding the derivative of 1 over cosine of x. Well, that is a ratio or a quotient, and we have a quotient rule. So let's try to do the quotient rule for secant here. The derivative of the top, okay, that's 0, times the bottom, minus the derivative of the bottom. Well, we said the derivative of cosine is negative sine, times the top, which is 1, all over the bottom squared. So we get cosine squared of x. Okay, so the first thing is 0, and negative sine makes a positive sign over cosine squared. Now, technically, we could kind of leave it like that, but most of us don't. We have a sine over cosine. Sine over cosine is tangent. And we have another cosine in the denominator, so it's secant. So the derivative of secant of x is tangent times secant. I'll list these in just a moment, but right now we're going to go through all four of these. Let's look at cosecant. So we want to find the derivative of the cosecant of x. That's going to be the same as finding the derivative of 1 over sine of x. And we're going to use the same properties. The derivative of the top times the bottom, minus the derivative of the bottom, which is cosine in this case, times the top, all over bottom squared. And again, we get negative cosine over sine squared x, just using our quotient rule. And we get here cosine over sine. We just know it's negative, first of all. Cosine over sine is cotangent. And we have one more over sine, so we get cosecant. And that's the derivative of the cosecant of x. Oops. Well, let's go ahead and look at tangent. the derivative of tangent of x. We don't know it, so we're going to change it to sine and cosine because I do know sine and cosine. Okay, so the derivative of the top, the derivative of sine is cosine, times the bottom is cosine, minus the derivative of the bottom, which is negative sine, times the top, all over bottom squared. Well, we need to simplify this and remember some of our trigonometry that we learned last year. Cosine squared is that first one. Minus minus makes plus. Sine squared over cosine squared. And we know that sine squared plus cosine squared is 1. And 1 over cosine squared is secant squared x. And the derivative of tangent is secant squared. All right, let's go ahead and do the last one here. Oops, that's not what I wanted. I want to do this. If we were to take the derivative of the cotangent of x using the same process we just did 3 times, d dx of cosine x over sine of x, the derivative of the top is, negative sine of x times the bottom, which is sine of x, minus the derivative of the bottom, which is cosine x, times the top, which is cosine x, all over the bottom squared. Okay, so then we get, negative sine squared minus cosine squared over sine squared. You can factor out the negative here, and negative sine squared minus cosine squared is actually a negative 1 over sine squared, and therefore that's equal to negative cosecant squared of x. So you notice that all you really need to know is what's the derivative of sine and cosine, and you can always create the rules for the other 4. However, memorization will be very handy if you were to memorize all 4 of these statements: the derivative of tangent, derivative of secant, cotangent, cosecant. Memorization will come in handy. One thing that I want to point out is something that might show up in the textbook problems is something called simple harmonic motion. It's basically saying if you had a weight at the end of a spring, if you pulled it down and released it, it would oscillate. And if there is no friction, buoyancy, anything like that, it would actually give you a trigonometric function. And if you're given the position function, we can find velocity by doing the first derivative. We can find acceleration by doing the second derivative. And the last piece is what's called jerk, and jerk is the third derivative, which is the derivative of acceleration. And that's basically saying, like, right when you let go of the weight, how much force is being pulled at you right away. I just kind of want to say that I may not have assigned this problem this year, but it's still a good problem to know. What I do want to do is a couple extra little examples here at the end, however. If I told you that f of x is equal to the sine of 3x minus 1, and I wanted to find the derivative of this function, we're going to have to use chain rule because the outside function here is the sine of x and the inside function is 3x minus 1. So the derivative of the outside would be cosine of 3x minus 1 times the derivative of the inside, which was 3. So we have to use the chain rule here and make sure we continue to follow that process. Everything still applies. Let's say we wanted to do cosine of x times the sine of, well, let's just go 3x minus 1. This is now the product of two functions, of which one of them requires the chain rule. So if I was to find the derivative of g, it would be the derivative of the first function, which is negative sine of x, times the second function, plus the derivative of the second function. Well, we said that was this, the 3 cosine of 3x minus 1 times the first function to begin with, and like that. So you have to remember that all of our properties still hold. We still need to do chain rule. We still need to do product rule, quotient rule, everything that we learned previously. Go ahead and check out the drive for your assignment sheet. I will print them off and have them for you guys tomorrow. But outside of that, if you wanted to get started, go ahead and look at your drive for what problems are coming up here. All right, I'll see you guys tomorrow. Have a good evening.